Hey everybody, this is Gregory from Dapp University, and today in this video I'm going to talk about deploying your smart contracts to a test network with a local development environment. Now I have another video where I kind of show you how to deploy your smart contracts to a test network with Remix, and this is kind of a point and click drag and drop method for getting your contracts on a test blockchain. But today I'm going to walk you through how to do it with your local development environment with some command line tools and a project framework like Truffle. And I'll be using the election decentralized application that we built in our previous tutorial on how to build your first decentralized application on the Ethereum network. So if you haven't seen that video, you can check that out. It's a full 2-hour video where I walk you through building your first decentralized application step by step. So be sure to check out that video if you haven't already, and subscribe to the channel if you'd like to see more videos about how to develop decentralized applications on the Ethereum network. Now, the dependencies that we need today in order to deploy this application to a test network, there's a couple. So really, if you've seen the other project video, I go through all the dependencies there. The main ones that we use for developing locally are like Truffle, the Truffle framework. That's just the framework that we use for building our smart contracts and testing them and building our client-side application. And Ganache for running a local Ethereum network and an in-memory blockchain. And also some other basic dependencies like Node Package Manager for installing dependencies in your development environment. And some of the things that I'll talk about today will be a little different for Mac users as for Windows users, as Linux users. I'm just going to be using a Mac today. I'll try to point you to other resources for doing this on your own operating system. So let's take a look here. The other big dependency that we're going to need today, which I did not cover in the other tutorial, is Geth. Now, Geth is a Go implementation of Ethereum. And this is going to replace the function of Ganache that we used in the other tutorial. Now, Ganache is an in-memory blockchain, right? And it varies a little differently from something like Geth, in that Geth is a full-blown Ethereum node, right? And we can use this node locally. Like I can start Geth to just have a local Ethereum node to develop with, but I can also start Geth as a full-blown Ethereum node connected to like a test network or the main network. So, you could essentially, mine Ethereum with Geth. You can just use it to be a node connected to the Ethereum network. And if you're kind of not really sure what that means, remember the blockchain is a peer-to-peer network made up of nodes that all talk to one another. It's decentralized, rather than talking to a central server. So when you are an Ethereum node and you're connected to the blockchain, you're kind of replacing some of the responsibilities that a centralized web server would have. That's kind of that's one of the defining characteristics of a blockchain. You can download Geth by visiting the Go Ethereum Git repository, and you can see the installation instructions here. This is the same website, sorry. Yeah, you can see the installation instructions here. This will vary kind of on operating system to operating system. Just follow through and follow these instructions if you want to get going. Now, once you have Geth installed and configured, you can start your Ethereum node by running Geth. It's pretty easy. Now, we don't want to start it with the default parameters. We want to connect to a test network. So we do that by using some additional parameters, and I have those listed here. All right, so here are the additional parameters that I'm going to pass to my Geth command. So I'll explain these. I'm going to use the Rinkeby flag. This is the test network that we want to connect to. Ethereum has a few different test networks. You can see that if you use like a MetaMask extension or something like that. You can connect to the main network or any one of these 3 test networks. I'm going to be using the Rinkeby test network for this particular example. So yeah, I specify the Rinkeby test network. I specify it's going to be an RPC instance, and I want to pass some particular things into my RPC API. And specifically, I want to pass in like personal, ETH, network, Web3, and net. And these are things that I'm going to be using when I'm interacting inside the Geth console. ETH is going to give me like for example, ETH is going to give me access to like my accounts and things like that. Personal will allow me to like unlock my account when I want to deploy my smart contract and things like that. I'll show you that here in a minute. And then I just specify the IPC path on my local development environment, and you can read more about that on the Geth installation instructions that I showed you on GitHub. So let's go ahead and start that. Now, whenever I boot this up, you can see that it's working. I'm going to stop for now, but just notice that whenever you do this, like whenever you're starting this Geth node, you're syncing with the testnet. So if I connected this to the mainnet, I mean, I would have to sync with the entire mainnet Ethereum blockchain. Now, I don't want to do that because it's big, so I want to use a testnet, which is still somewhat big, and it'll take some time. It might take you 30 minutes or so to get your test network synced. And if I start that, I can go to the the Geth console. I do that with Geth attach. I can see the status by typing eth.syncing. Well, syncing is false, so it looks like I'm actually up to date. But for you, if you're not up to date, you will see something like an object that shows you the block numbers. Here, let's actually just close it, see if I can get out of sync. Let's try again. Well, it's still false. So I've been running this in the background for a while, so it's in sync. But for you, if you typed ETH syncing, you would probably see an object that would essentially show you like the block number and how many blocks are left to sync. So you have to wait until that's done in order for your entire node to be synchronized, and you'll know that it's finished whenever you see ETH syncing and false. Now I'm going to exit out of the Geth console for now. And in order to deploy our smart contract, we need an account on the Rinkeby test network. So if you don't have one yet, we can create a new account with Geth. We do it this way. Geth, specify the network, Rinkeby, account, new. Now it's going to say your account is locked with a password. Please give it a password. Now don't forget this. Repeat it. Now, when you create this password, I would use a real password. Don't use like test password or 123. This is exposed to a test network. Now, it's not real Ethereum, right? Like no one's going to steal your real Ethereum, but it's still public facing, and I would use something that's secure. So here's the address of our account that we created. Now, I'm going to open the Geth console again. All right, you can see our node is synced. Now, we need to unlock our account that we created. So the account that we created, we're going to use to deploy to the Ethereum blockchain. And we can see our accounts listed here, eth.accounts. Whoops, that should be eth.accounts plural. All right, these are accounts we created. I've already created some, so you won't see this many. But we're going to use eth.account0 as the account that will deploy to the Ethereum blockchain, and that's what Truffle is going to use by default whenever we migrate our contracts. Now, if you remember, if you watch the other tutorial on developing the decentralized application, and you use Ganache, you remember that Ganache showed you all the accounts that were listed, and Ganache would default to the first account whenever you deployed your contracts or ran tests or anything like that. So that's essentially what we're doing here with Geth. We are creating some accounts that Truffle can use to migrate our contracts and run tests and things like that, and it's going to default to the first one. Now, after you create an account, like I said, you need to unlock it, and you also need to request some Ethereum. So when I create this account, it has a balance of 0 Ethereum in it, in its wallet address. So the other thing that we need to do in addition to unlocking it is to add some Ethereum to this account. We will do that with a faucet. We can go to rinkeby.io/hash faucet. And this will basically allow you to load your account with some Ethereum. And essentially what you'll do is follow some instructions. This is going to say, basically, you have to create a social media post with a hashtag and an address. So you basically would create like I did a tweet the other day. So it's going to say, requesting faucet funds into this account. So you would take the account that you just created, and without the quotation marks, and you would replace that here, and you would tweet it. I'm not going to tweet it because I have some Ethereum already, and the Rinkeby faucet will only let you request funds like every couple days or something like that. Like if you request 3, you have to wait 8 hours. If you request 7.5, you request 1 day, it's a day, 3 days. I think I did 18, so I've got to wait a couple days. So I'm not going to do that. But once you do, you would basically see a tweet like this come through in your social media account that would say, requesting this for this address. Also, whoops. This is actually my Twitter account, so you all can go follow this if you want to. You can reach out to me and ask questions, all that kind of stuff. It's just at Dapp University on Twitter. But this is what your tweet would look like. And once that's finished, you would see some progress here with your request, and it would go through. I should mention the reason that you have to do this on the Rinkeby network. You can't mine Ethereum on the Rinkeby network if you decide to just connect to it. That's because the Rinkeby network is a proof of authority algorithm. It's actually a different consensus algorithm from the main Ethereum network. And that the Rinkeby network only authorizes some nodes to be miners. And I know that's not really quite like a fully decentralized model. So it's fine for testing purposes. Essentially what it does is allows it keeps the network from getting really spammy, because the Ethereum's not worth anything, right? People will just willing to go and spend. They're going to spam your app essentially, and because the money's worthless and they have nothing better to do, so they try to prevent that on the Rinkeby network by limiting who can mine, and you have to request Ether with this smart contract faucet. So anyways, once that's finished, you can go and check the balance of your account. You would check the balance of your account with like this, ETH get balance, and we could do ETH.accounts 0. All right, and I can see this is the amount of Way that I have in my account. All right, so if you see any kind of number here, that means that your account has been loaded with some Ethereum. Again, this is just the Way amount. You don't actually have this much Ethereum. Again, Way, if you're unfamiliar, is the smallest subdivision of Ethereum. It's the smallest unit. I keep saying Ethereum. It's Ether cryptocurrency, right? Once you know that you have some Ether in your account, you want to unlock your account. Now, unlocking basically is going to give your account access to deploy your contract to the blockchain. And we do that with personal unlock account. And I'm going to do ETH accounts 0, which is the same account that we've been using. Now, there's a few ways to do this. Personal.unlock account supports a few arguments. I could just pass it the account here on its own. And this would essentially unlock the account, and it was going to ask me for a password whenever I hit enter. And I could just type the password in securely. So there's a couple ways. I could do it just with one argument. I could do it with 2 more arguments, which would be I could pass the password next, my password. But I don't want to do that because I don't want to show you on screen, and I would suggest that you don't do that either. And then I could also pass the amount of time that I want to unlock this account for, let's say 20 minutes, right? So I would express that value in seconds, which would be 1200 seconds is 20 minutes. So I could do that like this. Now I could also pass null for the password. Since this is a, oops, typo, sorry guys. Personal unlock account. I pass null for the password and I type in the passphrase. This was the passphrase that you entered when you created the account. All right, so I have unlocked this account for 120 seconds. Now you could you could just do one argument here and type, personal.unlock account, and not pass these other arguments, but your account, I'm pretty sure, will be unlocked indefinitely until you type personal lock account to relock it. There may be some sort of default time that it's unlocked for, I'm not sure, but I like to specify a time to ensure that my account is not just unlocked until I say so, in case I forget to go, lock it again. So that's what I do. So now we have some Ethereum or Ether cryptocurrency in our account, and we have it's unlocked, so we can deploy it. And remember, we need Ether in our account because writing data at all to the blockchain always costs gas. And that gas is going to be some amount of Ether cryptocurrency. So we need gas in our account. We need Ether in our account in order to deploy our smart contracts to the Ethereum blockchain. And that's exactly what we're going to do right now. So let's go to our Truffle project. We're going to add some configuration here. Go to Sublime Text. This is our election project from the tutorial that we created earlier. And we're going to go to our truffle.js. And you can see this should look like the configuration file that you used when you were developing the tutorial. And we're going to add an additional network here. I'm just going to paste in some configuration from another project. It's going to look like this. So this is going to give us a new network. This would be the Rinkeby network. Be a host, will still be local host since we're running our Ethereum node locally. And this is the port, 8545. This is the default for Geth, whereas Ganache uses 7545 to avoid collisions, which is nice. And the network ID is going to be 4. Now, this is the default, well, not the default, this is the actual network ID of the Rinkeby test network. Other networks, I believe 1's the main net, 3 is like Ropsten, things like that. So I'm also going to specify the gas limit so that we don't run into any issues whenever we deploy this contract. So this is the same configuration file that you would use. Once that's done, we're going to save this, go back to the console. I'm going to open a new tab here so we can keep our Geth console running and also our local Geth node. Now that our contract is unlocked and now that we have some Ether and we have a configuration file in our Truffle project to tell it how to deploy to the Rinkeby network, we're going to run Truffle migrate -- reset, just in case you try to do this more than once. And I'm also going to pass it the compile all flag. And I'm also going to pass it the network that we want to deploy to. And it's going to know this network name because we specified it here in our configuration file. Now let's see what happens. All right, so that finally finished for me. I went ahead and paused the video for a second because it was taking so long. Yeah, this will normally take a minute or two. I got some compilation warnings here, so if you see those, don't worry. They're not actually errors. They're just warnings. So yeah, this worked. I can see that this deployed migrations and it successfully saved all these to the network. And we have addresses for the contracts that we deployed. So what we can do is take one of these addresses. So we can see the election contract address here. We'll copy that. And we will go to a blockchain explorer like Etherscan. Now here I am on Etherscan. And now be careful and ensure that you are on the Rinkeby network for Etherscan. Actually, this is an old contract. I'm going to clear that out. Ensure that you are on the Rinkeby network for Etherscan. Don't go to etherscan.io without specifying the network first. That would take you to the Ethereum main network. So what we can do is search for our contract by address. That's the address that I copied from the clipboard. And we can see that here are the transactions related to that address. And we can see that this is have a successful contract creation. And that's one way that you can verify that your contract was actually deployed to the test network. And it's nice, you'll be able to see like all the transactions related to this contract as you use it on the test network. So let's go back to our development environment. Let's go to the Geth console. And let's try to interact with our smart contract on the Rinkeby test network. Now this is where it's kind of cool. We can use the Geth console like the Truffle console that we use in development, but we can actually load up our smart contract on the testnet blockchain and do stuff with it. So this is important. Like if you deployed a smart contract to the blockchain and you needed to do something with it before you made it live to the public and exposed it to a Dapp. Maybe you needed to transfer some ether to a smart contract. This is a great way to do it. You can do it in the console as a developer. So I'm going to show you how to do that right here. So the first thing we need to do is go look at our contract address. I showed you that. Let me show you one more thing. Status, we can see that in addition to our configuration file, our build/contracts file was updated, and I'll show you one way that you can find out your contract address. Build contracts, let's go to election, go to the bottom, and we can see that here are our networks. Network ID number 4, this is what we added to our configuration file. Here is the address of your contract on the Ethereum blockchain. This is one good way to reference it anytime that you want to fetch that. So I'm going to copy it here. And I'm going to load the console and just contract address. All right. The next thing that we need to do, now that we have the contract address, is we're going to copy the ABI for this contract. Now, the ABI is the application binary interface. This is basically how your Solidity code is encoded and decoded for the Ethereum virtual machine. Well, it's encoded for the Ethereum virtual machine, and it's decoded for you to use it for like contract, interaction and things like that. That's like what this ABI allows you to do. So I'm going to minimize this. I'm going to copy it. Right, I just copied this JSON array inside of this file. That was under the ABI key. I'm going to copy it, and I'm going to minify it. I'm going to paste it in here. This is just a website that allows me to take this entire JSON object and convert it to a single line. I'm going to minify. I'm going to copy it. The reason I'm doing that is so I can paste it in my console easily. Now you could do this with a script. You could read the file in the Geth console, but I'm just kind of trying to show you explicitly what I'm doing here. We'll type this contract ABI equals this JSON array, single line. So I assigned this to the variable of our contract ABI and just pasted in this JSON array here. So now we have the contract address, and we have the binary interface for the contract that we need to actually load up our contract. So I'll show you the next things that we can do here. Let's do this. So let's create a variable to assign the election contract. And we'll do this. web3.eth .contract. This is going to give us a contract from the contract ABI. Again, this is the variable that we just assigned. All right. You can see election contract here. All right, we have a representation of that ABI that we just passed. You can see the ABI here, and this is the Web3 representation. Now we can take this and actually create an instance of the contract. Now this is the cool part. So we can say var election instance. You might have seen that several times whenever we used the Truffle contract in the Truffle console or the front-end application in the other tutorial. So I can say election instance is going to equal election contract. We say at, and then we pass it. We pass it the contract address. Remember, contract address is the address we just pasted in the console a minute ago. All right, so var, so let's actually access that. Boom, we actually have an instance of this contract. Now, let's try to call some functions from this. These are the functions that we defined in the other tutorial. I'll just pull up Sublime Text for reference. Election.sol. Now let's try to read one of the candidates out of this candidates mapping. Remember, whenever we created this contract with the constructor, we created two candidates. We added a candidate here, candidate 1, candidate 2, and we added them to the mapping. So let's try to read one of those candidates out of the mapping in the console. Selection instance, we'll call candidates. Again, this is a getter function that Solidity provides us for free. So pass candidates, and we'll pass it candidate 1. Boom. So we have candidate ID of 1, the name, candidate 1, and its vote count. So now these are the values for the actual candidates mapping on the test network. So we have successfully deployed this smart contract to the test network. We have interacted with this smart contract on the test network with a Geth console with a full-blown Ethereum node. Now remember, Ganache is just an in-memory blockchain. This is a full-blown Ethereum network. A full-blown Ethereum node. We're on a test network, and you could do this on the real Ethereum network. I just don't want to play around with it for a demo because it would cost me real ether in order to deploy the contract. So I'm not going to do that. But yeah, this is big. I mean, this takes you from just developing a toy on your computer to actually pushing out there in the wild, where you could do something like develop your own Dapp and have other people use it. So that's the power of what we've done here. Now, if you would like to see another video about how you could deploy your client-side application from this tutorial to, the web to talk to your smart contract on the blockchain, be sure to subscribe to the channel and let me know if you would like to see that kind of tutorial. Leave a comment down in the comment section below, or you can reach out to me on Twitter and let me know if you would like to see that video there. Also, if there's any other videos that you all are particularly interested in, feel free to give me a shout on Twitter or leave me a comment down below. Again, the Twitter handle is Dapp University. You can just search that on Twitter. It should be easy to find. So hope you all liked that. Be sure to subscribe to the channel to see some more videos about how you can build decentralized applications on the Ethereum network. And until then, thanks for watching Dapp University.